Pulkit, the streaming has started.
About the co-host. Hello?
Yeah, Pulkit?
Yeah, I am talking about the co-host. You didn't make me co-host.
Yeah, sure.
Yes. Hello everyone. Am I audible?
Yes, sir.
Yes, sir.
Yeah. So first of all, there's some network issue from my side. So if in the session in between my screen stops or I didn't like the screen stop sharing and all, so just let me know. Okay. Okay. Yeah. So my screen is visible to all of you.
Sir, your voice is
Yes,
continuously.
sir.
Yes, sir.
Yes, sir.
Yeah. As I said, like there's some network issue from my side. Okay, so probably because of that. Uh, Okay, so today I will. Okay, yeah. Hmm. So first, let's discuss about the course outline itself. Okay, so
Sir, it's too much
our course
break.
mathematics for data science too. Okay, it mainly we divide our. Okay,
Sir,
just
your voice is not clear.
okay, just a minute then. Is it okay now?
Yes, sir.
Yes, sir.
Hello.
Yes, sir, it's
Yes,
okay.
sir.
Yeah. Okay. Okay. So I hope my screen is visible.
Yes, sir.
Okay. Hmm. Okay. Yes, Devanshu, any doubt?
No, continue, sir.
No? Okay. Okay. Yeah. So I was talking about the basic course outline first. Okay. So if we primarily divide our course, like there are basically two parts. Okay. Two major concepts in our course, linear algebra and the multivariable calculus. Okay. So the first 8 weeks in our course would be on linear algebra. Okay. And the last 3 weeks would be on our multivariable calculus. So total mathematics for data science 2 is of 11 weeks course. Okay. Out of which first 8 weeks would be from linear algebra. Okay. And the last 3 weeks would be from multivariable calculus. Okay. Just like we have single variable calculus in our maths 1, we had multivariable calculus in maths 2. Okay. So in first week, the major concept that we have are vector and vector operations. Okay. What is vector and their operations? Same. Matrix and matrix operations. Then system of linear equations and determinant and its properties. Okay. So that's what we are going to discuss today, the first week, and we will solve some questions on that. After that, I will take your doubt on activity questions like that. Okay. And there's I have created one post on the Discourse. Okay. I hope all of you had access to Discourse.
Yes, sir. Yes, sir.
Yes, sir.
No, sir, we haven't got invite. This is direct diploma student. We haven't got invite yet. When we send a mail, they said we will get the invite soon.
Yeah, so direct diploma, I guess there's problem every time in direct diploma. I don't know why. So you will get soon, don't worry, okay?
Yeah. Okay.
So
Thank you, sir.
it was just that I have created one post on the Discourse, okay? So if you go into the Maths 2 category, okay, there's then this one post
So
that
when
will be
we
pinned
sign
to,
in later, will this resource free still be there?
yeah, it will be there, okay?
Thank
And
you.
it will be pinned comment, okay? Or you can always search on the Discourse, there will be one search, you can search the title of the post, Maths 2 Resources by TA, okay? So you will find these resources there, okay? The second point is here. Here I will upload the TA session PDF, okay? Whatever the session we are going to have, all the PDFs I will upload, okay? And this was the last term PDF folder, okay? The first one actually is week-wise question bank, okay? Like till now we had 6 or 7 terms in Maths 2, okay? So till now, whatever quiz has happened, quiz 1, quiz 2 or n term, okay, all the questions week wisely are available here, okay? You can check that here also. And there's some book and the PYQ sessions that happened previously, okay? The recordings and the PDF are available here, okay? This is actually the link where you can access the PYQs only, okay? Not only for Maths 2, here you will get the actual question paper that you get in the exam, okay? The answer keys. And rest other are the things that you cover when we proceed towards the, because they are related to some specific week, like these are for 5 and 6, and then 8, okay? And these are like some special week which you need to more put more focus on, okay? Week 5 and 6, week 8, and the multivariable calculus, okay? That's all, okay? And about the session, okay? Instructor session that are going to always happen on Thursday and Sunday, okay? While TA sessions usually will going to happen on Tuesday and Saturday, okay? And usually in the term, the first session was not for the TA, why yesterday ma'am has on some special occasion only the days will change. Otherwise, these are, you can say, the fixed days. And timing will be always 8 to 10. Okay. Yeah. So now we'll start on our week. Okay. So we have vectors in our week one. We introduce vectors. Okay. If we just are okay, start with the smaller. Then
Hello.
just R2 can be represented.
Hello.
Yeah.
Hello.
Yes.
Am I audible?
Hello. Yeah. Yeah. Yes,
Your
Vikas.
voice is breaking.
Okay. Is it like breaking too much?
Actually, sir, I was
Yeah, yeah.
one of
Speaking too much.
background noise.
And
I think someone else is
can you tell
talking.
me what is this session about?
Uh, see,
Like we are
here
going to
we are
discuss
mainly
a
going to
topic or going to
discuss
solve this question?
question. Yeah. Okay. So I guess I should do. Yeah. See, there's a little bit network problem. I mean, probably because of that, the voice is lagging. Okay. If it lags too much, then tell me. Now?
Yes, so it's lagging.
Yes, sir.
It's not lagging, sir. Actually, it is breaking. The voice is like.
Okay. Just a second. Okay. I'll ask the other tier to join the session. Okay. If it breaks too much, then we will try to switch the place. Okay. Okay. So vectors in R2 are represented by an ordered pair. Okay. A comma B. The first element in this ordered pair would be from the x coordinate. Okay. And the second one denotes the y coordinate in the Cartesian plane. Okay. Cartesian plane means for R2 case, you can consider our xy plane. Okay. So in R2, we represent our vectors in a pair of A comma B. Okay. Where A and B can be any real numbers. Okay. Similarly, in any Rn, we can represent vectors. Okay. Like this. Aradhna, are you there?
Yeah, I'm here.
Yeah. So please tell me if like my voice breaks too much. Okay.
Okay, will do.
Yeah. Okay. So there are like basic vector operations that are there. Okay. Those are like addition of the vectors. Okay. So if we have two vectors in R2, okay, the addition that happen in the vector are coordinate wise. Coordinate wise means the first coordinate, okay, will get added with the first coordinate. The second coordinate will added with the second coordinate. Okay. So that's how the vector addition is going to happen. Okay. And if we talk about scalar multiplication, it is also the same. Okay. Scalar by scalar multiplication. Okay. Yeah. So let's run this basic question first. Okay. So 2a is the vector 2 comma 4. We have a vector a that is 1 comma 2. Okay. It's 2a. Okay. So we are multiplying the scalar 2 to the every element in the vector. So what it will be?
2,
2,
4.
4.
2,4. Okay. Yeah. Similarly, 3b. My vector b is 2, 3. We are multiplying every element vector by 3. So it would be 6, 9. Okay. Plus is 1, 3, 1, 2. And b is 2, 3. So a plus b is 3, 5. Okay. So it is also true. And if we talk about a minus b, so coordinate wise subtraction. Okay. That is -1, -1. Yeah. This was one basic question. Okay. These are in the first week, basically like there are the topics that you may study in your school if you had maths background. Okay. But some of you might not. Okay. So first we'll go through the basic things. Okay. After that, we will move on to the main questions that we have today. Okay. So I hope
Yes.
this question is clear for everyone.
Yes, sir.
Yes. Yes, sir.
Yes, sir.
Yeah. Yeah. So matrix. Okay. Matrix nothing but the vectors we are taking. Okay. We are putting them either you can say row wise or column in an array. Okay. And that array is called the matrix. Okay. So you can consider that the columns of these matrices and also the rows of these represents our vector. Okay. So as we have scalar multiplication vectors, we have the matrices. Okay. So the addition in the matrices is also going on.
Sir, your voice is lagging, sir.
Yes, sir.
Sir, it's actually echoing,
Sharp.
not lagging, but it's echoing.
It was lagging.
Sir,
Sir,
echoing.
it's lagging, sir.
Yeah, the
Echoing,
voice was
sir.
breaking.
Lagging, sir.
Sir, please reconnect.
Just hold on, everyone. Pulkit is going to be joining in just a couple of minutes, fixing the net issue. Give us 2 minutes.
Yes. Okay. Is it okay now?
Yes, sir.
Yes, it is.
Absolutely
Yes, sir.
fine, sir.
Okay. Great. So addition of matrices. So the matrix addition is also going to happen the coordinate wise. Okay. Like first coordinate in the you can say first element that we represent at the A11. That means first row, first column. Okay. That element is going to add with the first row, first element, first row, first column element of the second matrix. Okay. And like that for each element it's going to happen. Okay. But if we talk about the case for multiplication of two matrices, remember here in mathematics we don't talk about the multiplication of vectors, okay? That case is not considered here. However, in physics we consider the case for multiplying vectors, okay? But here we don't consider that, okay? We only, for vectors we have only two operations, addition and scalar multiplication. On matrices we have three, okay? Addition of matrices, scalar multiplication on matrix, and multiplication of matrix, okay? So yeah, multiplication in matrices. Let's suppose you have a matrix A which rows are represented by R1 and R2, and a matrix B whose columns you are representing by C1, C2 and C3, okay? Then the product AB is defined by this, okay? That means first row multiplied with the first column, okay? And whatever that output will come, okay, will consider as a 1 month entry of our product matrix, okay? Similarly, first row multiplied with second column, okay, that would give me my 1/2 element of the product matrix, okay? And similarly like this. Now, what will happen is addition of two matrices is only defined when both of them are of the same order, okay? While for the multiplication, okay, if A has m rows and, okay, if A has m rows and columns, then B has to have n rows and p columns, okay? That means the columns of the first matrix has to be same as the rows of the second matrix, okay? Then only the product AB is well defined, okay? And the matrix you will get would be of order m cross p, okay? Yeah. So suppose we have a matrix P here, Q, R and D, okay? Now, the matrix PD is of order 3 cross 1. P is of order 3 cross 3. D is of order 3 cross 1, okay? If we check as before, yeah. So the matrix PD would be of order 3 cross 1, right?
Yes.
Yes, sir.
Yes, sir.
The columns of the P matrix is same as the column rows of the D matrix. So the matrix multiplication is possible here, okay? So the matrix PD you will get would be of order 3 cross 1, okay? And let me just multiply this matrix, okay? So we get a clear understanding how we multiply the matrices, okay? First row multiplied with first column, okay, and that will give us the 1 month entry of our matrix multiplied, okay? So 3 multiplied with -2 -6, okay, then plus -1 multiplied with 4 -4 plus 7 multiplied with 5 35, okay? That would give me my 1 month entry, okay? First we know that okay, the matrix you will get would be of order 3 cross 1. That means it will have 3 rows and 1 column, okay? So the entry we will get here would be -10 -20 plus 25, okay? Now same second row multiplied with first column would give me my 2 month entry of my matrix, okay? So -8, 0 multiplied with 4 0, 1 multiplied with 5 5, so -3. And third row multiplied with first column, okay? So -4 -20 plus 10, okay? So -14, okay? So that's how we multiply the matrices, I hope it is clear.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Yeah. So the matrix QD would be of order 3 cross 3. What is the order of Q matrix? It is 1 cross 3 or 3 cross 1?
1 cross
1
1.
cross 3.
Cross 3.
1 cross.
Cross 3.
Okay. Columns are like vertical and rows are horizontal. Okay. And D is of order 3 cross 1. Okay. So is the matrix multiplication possible?
Yes, sir.
Yes, sir.
And what would be the order?
1 cross 1.
1 cross
1.
1 plus 1.
Now if we check for D and Q. D and Q. D is of order 3 cross 1. Q is of order 1 cross 3. What would be the order of DQ matrix?
3 cross
3
3.
cross 3.
3 cross 3.
Okay, the product QD is not defined. We have already checked for QD, so if it is wrong. Okay, the product QR is not defined. R is of also order 1 cross 3. Okay, it is not defined because the columns of the Q matrix is not same as the rows of the R matrix. Okay.
Yes, sir.
Now, the reason to study for matrix and vector is because we are going to use them to solve our system of linear equations here first. Okay, this is the first use that we are going to use them. Okay, so we have a system of linear equations. Okay, any system of linear equations would be like this. Okay, this is an, you can say, general example where we have 3 variables, okay, and 3 equations in linear form. What is mean by linear form here? What is
The
mean by,
highest
you can say,
Degree is 1.
the variables have highest power as 1.
yeah, correct. You can also say that degree is 1. Okay, so that is what it is mean by linear equations. Okay, so if we have any system of linear equations, okay, then the matrix representation of the above system we will call as Ax equal to B, where A is called as the coefficient matrix. That means whatever those coefficients are there, okay, we will put them in one matrix. Okay, to form, okay, just we have this equation a11x1 plus a12x2. Okay, the first equation here. So just write this first equation. Okay, is my screen visible?
Yes, sir.
Yes, sir.
Yeah. Okay, thanks. Yeah. Okay, Na13. Just write the first equation without the variables. Okay, that would give you a first row of the coefficient matrix. Okay, same do with the second equation and the third equation as well. Okay, so that's how we will going to form the coefficient matrix. Okay, now this was the case for 3 equation 3 variable. You might nowadays get the square matrix. Okay, like if we have 5 equations with 2 variables. Okay, like that also. Now tell me one thing, just as I said, if we have 5 equation 2 variable, then what would be the order of the matrix? Five equations with 2 variable, then what would be the order of the matrix A?
5 cross 2.
Correct. Okay, so basically the columns, okay, the columns basically represent the number of variables. Okay, right, because that you can say how many variables are there. Okay, that much columns will be there. Okay, and the rows represent the number of equations. Okay, so as I said, 5 equations with 2 variables will give me a matrix of 5 cross 2. Okay. So remember this thing. Rows here represent number of equations. Columns here represent number of variables. And now let's move on to the second part, X. Okay. X is basically, you can say, your variable matrix. Okay. This matrix stores the variables. Here we have variables x1, x2 and x3. So we will store them here. Okay. Like this. Now if we have x, y, z, then x would be just my simply x, y and z. Okay. And if we have, let's say, some different variables x, y, z, w. Okay. 4 variable. Okay. So as much as variable are there, that would be my rows in the matrix X. Okay. And B is called as, you can say, resultant matrix. Okay. That is the RHS side of the each equations. Okay. That what comes under B matrix. Okay. So suppose there are m numbers of equation and n numbers of variables in the system of linear equation, then the coefficient matrix would be of order m cross n. X will be of order n cross 1 and B will be of order m cross 1. Okay. Now one small question on this first. We have a system of linear equations. Okay. If the matrix representation of the system 1 is X equal to B, then now what would be my A matrix? How we are going to form? We will write the equations without their variables. Okay. So first equation, it is -2. Now first identify the number of variables in this equation. How many variables are there?
3.
3, right? So there would be 3 columns, and as there are 3 equations, so it would be of order 3 cross 3 first. Okay. In first equation, it is -2x1 plus 3x2 plus x3. So this, okay, that would be my first row. Now for second row, -x1, so -1. Now there is no x2, okay, so it would be 0. 0 times x2 plus x3, so 1. Now in third equation, there is no x1 and x3, so 0 times x1 plus 2 times x2 plus 0 times x3. Okay, so that would be my matrix A. Okay, that is this. And B is just simply this. Okay, 1 0 5. So this one. Okay, so I hope this much is clear to all of you.
Yes, sir.
Yes, sir.
Yeah. Now comes the last part. Okay. Okay. Yes. What's your doubt? Someone has raised hand. No. Okay. The last part is determinant. After that, we will solve some practice question that I choose from. Okay. So determinant for 2 cross 2. Okay. 1 cross 1 part is missing. Okay. If we have a matrix of order 1 cross 1, what would be its determinant? Let's say this is my matrix 1 cross 1, which has the entry A. Then what would be the determinant of A here?
A.
Okay. For 1 cross 1, it would be just the same element that is there. For a 2 cross 2, okay, the matrix 2 cross 2 is here. Okay, A, B, C, D. Then the determinant of A would be AD minus BC. That is product of diagonals. minus BC. Okay. And one thing also, in matrix we only consider this as a diagonal. Okay. This side is not considered as a diagonal in the matrix. Okay. Yeah. So this was for the 2 cross 2. For 3 cross 3, what we have to do is make the submatrix. Okay. So you can fix any row or column. Okay. You can start with any row or any column in the matrix. Okay. Here the example that is given is with the first row. Okay. We are fixing the first row. Then what we are doing is we will take the A11. Okay. Then you can hide the elements below that and in the adjacent elements. Okay. Now you have the 2 cross 2 matrix. Okay. This. Multiply A11 with the determinant of that submatrix. Okay. And because we are going along with the first row, okay, the same thing you have to do with the rest two element. Okay. All you need to do is take care of the sign. Okay. Like here it is coming minus, here it is coming plus. Okay. So how the sign is defined, that you need to take care of. Now to remember the sign, what you can do, if the entry of the element is at even position, that means let's suppose A23. Okay. It is second row, third element. Okay. Just sum up the row and columns. Okay. That is 5. Okay. This is odd. If this is odd, then the sign that will come would be negative. Okay. Now, for let's say 2, 2, 2 plus 2 is 4. If this is even, okay, then the sign would come as positive. Okay. Now, as we were going along the first row, okay, A11, 1 plus 1 is 2. It is even. Okay. So, sign that will come would be positive. Okay. So, it will be just A11 multiplied the determinant of some matrix. Now, we are going along the A12. Okay. So, we are going along A12. Now, 1 plus 2 is 3. It is odd. So, the sign that would come would be negative. Okay. So, negative A12 multiplied same. Okay. Like hide all the element below the A12 and in the adjacent. Okay. And whatever the sum matrix you left with, take the determinant of that multiplied with A12. Okay. Same with the case for A13. Now A13, 1 plus 3, 4. Okay. Even. So the sign would come as positive. Okay. Now see, here it is written as expanding with the respect to first row. Okay. You can do it with any row or column. Okay. The determinant you will get would be the same. Okay. Yes. Any doubt? Anyone till now?
No.
Great.
Excuse
Now,
me, sir.
here are, yes.
Sir, I want to know how we can find a determinant of larger order, like say 5
Okay.
or 6.
Larger or the same case. Okay. Like if you have 4 cross 4, okay. A11, A12, A13, A14, okay. A21, okay. Like that. Then same, fix any row or column. Okay. Let's suppose I am going along the second row. Okay. Then A21. What is the method? Okay. Remove all the elements. Okay. Now you have left with a 3 cross 3 sum matrix, right? And you know how to find the determinant of that. Okay. Multiplied with A21. Okay. And similarly you have to do for the this whole second row. Okay.
Sir, order 4 is okay, but how can we do in for like order of 8 or 7.
Yeah, see, that much is not going to ask in the exam, okay? If it is asked, then the matrix would be of some special kind, where like the entries are mostly 1 or 0, okay? So if in the exam the higher order matrix determinant is asked, then either the calculation will be easy, or you can easily able to find out through some properties of determinant, okay?
Okay, sir.
But there's only one way to find the determinant for each matrix, that is this, okay?
Okay, sir.
Yeah. So, any other question, anyone? Okay. So, there are, okay. Yes, Sunita?
Sir, actually, I wanted to ask that when we find determinant of A, we represent the system of linear equations in the form of a matrix, and then we take out the determinant. So, what does this determinant tell us with respect to the linear equations? I mean, what
Okay,
is its
I guess that
relation
part
with
is not
respect?
covered in week 1.
Okay.
See, that part is, I guess, not covered in week 1. This you will find in week 2. Or I can just tell that, first of all, determinant we only can find for square matrix, okay? If we have
Yes.
a rectangular case, we cannot find the determinant. Determinant is only for the square matrix. And if determinant is non-zero, okay, that means the system of linear equation will have unique solution. Okay. If determinant is 0, then the other two cases will happen. That is no solution or infinitely solution.
Fine.
Okay.
Okay.
That thing I guess we will cover in week 2. Okay. Don't worry about it.
Okay. Thank you.
Okay. In week 2, you mainly will study the solution of system of linear equations. Okay. How we can solve the system of linear equation using matrices. Okay. That is what all week 2 is all about. Okay. Yeah. Now, yes, Ramya, what's your doubt? You have raised hand.
So regarding determinants of a matrix for a higher order, you mentioned using properties of determinants, it is possible to identify. So can you give us an idea of what properties you mean or how we can apply?
Yeah, that's what I'm going to discuss now. Okay.
Oh, sorry.
Okay. Yeah. And someone posted a doubt from the activity. Don't worry. First, after that, I have some questions. Okay. Like after this part, I have few questions. Okay. Like these are like 3 or 4 some questions. After that, I will take your doubt from activity or practice assignment. Okay. No, I guess from practice assignment we had deadline on Sunday, right? So from activity I will discuss. Yeah. So before going that, we have to first study about the row operations. Okay. The elementary row operations.
Hello.
There are 3 row operations. Okay. Yes.
So I wanted to ask that, like we have been taught scalar multiplication of the matrix. What is scalar addition of a matrix?
Scalar addition. Where is this term like came? Is there somewhere written in the book or?
Sir, there's one of the questions in the practice assignment in which there's one option given, and there's a term scalar addition of a matrix is mentioned.
On which question? Can you tell?
So yeah, this is practice assignment, question number 2, the last option.
Okay. that and
Hello. So your voice is breaking.
yeah, so we are looking okay, yes again. Okay, so let's do one thing first. Let me finish this, okay? I don't like. Okay, after that I will take that.
Okay.
Is my voice still breaking?
Yes, sir.
Yes, sir.
Okay. Can hello?
Yes.
Yeah, Pulkit, now you're
Yes.
audible.
Okay. Yeah. Okay. Yeah. So we were discussing about the first. Let me complete this, okay? Because the internet is not with me today. Okay. After that, I will like discuss what is this. Okay. Yeah. So we have elementary row operations. Okay. There are 3 row operations. The first one is interchanging the rows of a matrix. Okay. If we have a matrix, you can interchange any row. Okay. This is
Sir,
rows.
voice is still lagging.
Okay. Let me
Sorry guys, just some net issues. So I can take the scalar addition question that someone had. I'll just go through that. So scalar addition, what is a scalar? Can anyone tell me that?
Sir.
What is a scalar?
A real number.
Any real number. Yeah. So it's just any real number. So we can do scalar multiplication. We've seen that. But like matrix addition has this rule, right? What is the rule? Like you can only add certain matrices. So what is that rule?
Same order.
Same.
Yeah. So scalar addition means that you are adding one single number to a matrix. That's not possible. You can only add matrices with other matrices having the exact same order. It has to have the same number of rows and the same number of columns. Only then addition of matrices is possible. So scalar addition is not actually a thing. And scalar multiplication is, however, because you can take one number and you can multiply it to each value in the matrix, and that is what is scalar multiplication. And then later we have matrix multiplication, and that has its own rules. The first matrix has to have the same number of, anyone? What is the matrix multiplication requirement?
First matrix should have the same number of columns as the rows of the second matrix.
Yeah, so that is the requirement. And then the product has what? like what are the dimensions of the product matrix if
The
we
row of
can
the
multiply.
first matrix into the column of the second matrix.
Yeah, that's it. So that is what it is. So scalar is just one real number, so you can't add it to matrices. So if you want to add one exact same number to every single value in a matrix, what you have to do is take another matrix, make of the same order, and then make every value in that matrix this particular scalar that you have chosen, and then only you can add. So scalar addition is not a thing. You can only have addition of matrices. Okay, I hope that's clear. Okay, Pulkit, are you there?
Hello, ma'am. Please can you explain it again? I had lost the net connection.
Yeah. So the thing is, you can only add matrices with other matrices, and then you can only do that if they have the same order. So both matrices have to have the same number of rows and columns. That is a core requirement. Otherwise, you just can't. So a scalar is just a real number, right? So you can't have like 1 plus and then a matrix like 1, 2, 3, 4. It's a 2 cross 2 matrix. It has values 1, 2, 3, 4. Like 1 and 2 is the first row and 3 and 4 is the second row, say. Okay. And then you have a scalar, let's say 1. Okay. So you want to add 1 to each value of the matrix. That is your scalar addition you want to perform. But see, if you want that, what you have to do is create another matrix where you make each value of each entry of the matrix that scalar that you have chosen. Only then you can add. You can't take one single value and just put it like plus matrix and then add. So scalar addition is not possible. Scalar multiplication, on the other hand, is possible. You can take a real number value and just multiply it by every value in the matrix. So that is there.
Okay.
Yeah.
Thank you.
Yeah. Okay, any other general doubts till Pulkit like sorts out? Pulkit, are you there?
Yeah, but is my voice okay now?
It's better, but not very clear. So if you want to take some time, like fix the net situation, until then I can take some general doubts if anyone has.
Okay. Yeah, you can ask any doubt. Okay.
Yeah.
Ma'am, I have a question.
Yeah.
My calendar is not updated to not show classes.
Mm-hmm. Your calendar, as in the student Google account calendar.
Yeah, ma'am.
Okay, you just have to go to the course, the Mathematics for Data Science 2 page, and in the About page that opens up at the beginning, below you have the course specific calendar. Just click that link and it's going to get added to your student calendar.
Okay, ma'am, I will try it.
Yeah. Activity 1.1, question 5. Okay. Right now I'm actually not able to solve today this, but I'll open it up. I'll clear any conceptual doubts you may have, so you can solve it later.
Ma'am?
Yeah?
Ma'am, I have one doubt.
Yeah, please go ahead.
Ma'am, on Thursdays, there's a clashing session between Maths 2 and MLF from 8 to 10 p.m. So, ma'am, in office hours by TA, I inquired about the same and they said that either the Maths 2 TA will have to shift their session or the MLF TAs will have to shift their session. So, ma'am, whatever is possible will be a great help for us because MLF is a very new concept and missing any one class will be a problem. And Maths also, we cannot miss any class.
So the thing is, we don't really have the power to do that because we only have very specific slots. And also Maths 2 is foundation. So many more students join. So we have this very fixed spot. And MLF builds up on everything you learn on Maths 2 actually. So that is also there. So we will try. I'll tell this to ma'am. but our slot is actually very, it's been like the same slot since last term. We haven't been able to shift it. We wanted it to be another day or like in the afternoon so more students would attend or longer. This is what we have now. We'll talk to ma'am and see what we can do.
Yes, ma'am. Thank you.
Yeah. Okay, I'll open this activity and then I'll discuss it, and hopefully then by then Pulkit can sort this.
Ma'am?
Yeah.
Yeah. Okay, so
Yeah.
is my voice better now?
Pulkit, yeah, much better. Okay, you will take it from here. If you
Yeah.
have any general doubts, guys, you can put it in the chat. I'll answer. I'm here only. But let's let the session continue as planned so that we can go through week 1 and then move on to more. Okay?
Yes. Yes, Jainab. What's your doubt?
Good evening, sir. Hello.
Yes.
Sir, I don't have access to Maths to Discourse forum. I have mailed support many times, but there was no response.
Okay, so could you please drop your mail ID in the chat box?
Okay, sir. Thank you so much, sir.
Yeah. Okay. So sorry for the net issue. Okay, I hope it is better now. So let's continue the session. We were discussing about the row operations and their relation with the determinant. Okay. First row operation that comes is interchanging the rows. Okay. If we have any matrix, okay, let's consider the case for a 2 cross 2 first. Okay. 1, 2, 3, 4. Okay. Then what can happen is we can interchange its rows. Okay. This is row 1. This is row 2. Okay. We can interchange these two rows. If we do that, then this would be my new matrix. Okay. Now, same we can do for a 3 cross 3 or does not necessary to be always square matrix. Any rectangular would be also be work. Okay. So the main point is if we interchange any two rows, the this operation will also effect on the determinant. Okay. On interchanging two rows, the determinant sign would become negative. Just as first here the determinant is, what would be the determinant for this matrix?
Minus
Minus 2. Okay. And what about the determinant of this new matrix?
2, 1. 2.
2. Okay. What happen is it get negative of the original matrix. Okay. So interchanging two rows will change the sign of the determinant. Okay. Now for second one, that is multiplying a real number. Okay. Multiplying a real number with a row and adding it to some other row. Okay. That is 3, 4, 5, 6, 7, 8, 9. What I will do, I will take the second row, okay, and in the second row, I will add the 3 times of first row. Please mute your mic. So that means my first row will remain as it is, okay, because the operation that I am doing is on the second row. Okay, what I am doing, I am adding the 3 times of first row in the second row. Okay, now as we discussed, we can see the rows and columns of matrix as a vector. Okay, so this is my vector. Its 3 time would be this, and I am adding it to this vector. Okay, so coordinate wise addition. Okay, and that what would become my second row of the matrix. Okay, and the third row will remain as it is. Okay. So what it is saying that this operation does not change the determinant. That means whatever the determinant was it before, the determinant after it, this operation would be the same. That means the determinant of original matrix and the determinant of transformed matrix would be the same. Okay. You can try calculating it. Okay. Now for the third type, the determinant of a, okay, it's need not to be square always. Okay. Oh, sorry. Yeah, it's need to be square. Only then we can talk about the determinant. The determinant of a new square matrix obtained by multiplying a, yes, any doubt? No? Okay. The determinant of a new square matrix obtained by multiplying a real number C with a row of a square matrix of order n is C times the determinant of the original matrix. Okay. So the third operation that it is you can say the sub part of the this second operation. Okay. Like here, I am multiplying the second row by 3 times. Okay. So what it would become? Okay. This is my third operation. And the change in determinant would happen is if this determinant of A is X, okay, then here would become my 3 times X. Okay. Now, tell me one thing. If this is my matrix A and I am saying the determinant of matrix A is X, what would be my determinant of matrix 3 times A? It would be 3x, 9x or 27x.
3x.
First option is 3x.
3x.
Second option is x. And yeah. Which one?
3x.
27.
27x.
Okay. 3x. Okay, so the correct answer would be 27x. Okay. Now the reason. Okay. See, here in the operation what it is tell is if we multiply only one row, then my determinant is multiplied only one time. Okay. But if I am doing is 3a, scalar multiplication, in scalar multiplication what happens? Each element in the matrix is multiplied by that scalar, right? That means each row will be multiplied this with this 3, right? Okay. With one time it would be 3x. With if we are going to do it 3 times, then it would be 3 power 3 x. Okay, that is 27x. Okay. So for a general formula that you can remember is if determinant of matrix A is x and my matrix A is of order n cross n, okay, then the determinant of, you can say, r times A would be r power n times x. Okay, because that r would be multiplied to each row, and how many rows are there? N row. Okay, so r power that n times original determinant. Okay, is this
Yes.
thing clear?
Yes.
Okay, so
Yes,
in
sir.
this students sometimes make mistakes. Okay, and remember determinant of 3a is not same as 3 times determinant of a. Okay.
I'm so sorry.
Oh.
Can you explain this one again?
Okay, this part. Uh,
Yeah, I mean,
the third row operation.
yeah. Is the answer here 27x?
Yeah, correct answer is 27x.
So how did we get 27x?
Yeah, okay. So this part was clear, right? That on applying the third row operation, the determinant would become the scalar times of original, right? If we're
Yeah.
multiplying any row in a matrix, okay, with some scalar, then the change on the determinant would be what? The determinant would also be multiplied with that scalar. Okay. But here what we are doing is, this is my matrix A. Okay, what? This is my matrix A. I am doing 3 times A.
So we are multiplying
Scalar multiplication.
every element with 3.
Every element with. And you can also say that each row is getting multiplied with 3. Okay. Correct?
Yeah.
Okay. And if I'm only multiplying only one time, okay, here we are doing it only one time, then this is my determinant. Here we are doing for R2. If same I will do for R1 and R3 also, then it would be what? Now here it is 3x. If I
Okay,
am
so
doing now R1 multiplied with 3 times R1, okay, then it would become 9x, then 27x, okay?
okay, now I get it.
Okay.
Thank you.
Okay. For the general form you can remember is, if I have a matrix of order n cross n, and the determinant of that matrix is x, suppose, then the determinant of r times a, r can be any scalar, okay, would be r power n times x. That is, r will multiplied with each row, right? And that time x. So these were the properties of determinant with respect to elementary operations. There are a few more properties, okay? That is this, okay? That if 2 rows or 2 columns of a matrix are equal, then the determinant of that matrix is 0. Okay. And the second is, if all the element of any row or column of a matrix are 0, then also the determinant of a matrix is 0. Okay. That means if my matrix is this, that is one whole row or column. Yes, I will take doubt after this. Okay. Don't worry about that. Okay. If all the elements in a row or a column of a matrix are 0, then the determinant of that matrix is also 0. Okay. So these two properties you can remember. Okay. One property is determinant of A is same as determinant of A transpose. Okay. I will discuss what it is A transpose in the next phase. Okay. Yes, I will take doubts today only. Don't worry, Tia. Okay. Just let me finish this quickly. Okay. After that, I will take doubts. Don't worry. Okay. And the fourth property is determinant of product of matrices. Okay. Now, one thing always remember that in matrices, AB does not need to always equal to BA. Okay. If we talk about a real number case, okay, where x and y, let's say, are two real number, then whether you multiplied xy or yx, those would always be same. But in matrices, the product need not to be always same. Okay. But while if we consider that for the determinant, then the determinant of AB matrix would be same as the determinant of BA matrix, and that is also equal to determinant of A times determinant of B. Okay. And a few more properties are there. Okay. That is, determinant of A is equal to 1 by determinant of A inverse. Okay. What is A inverse? I will also talk about that in the next page. Okay. So yeah. And remember, determinant of A plus B is not equal to determinant of A plus determinant of B. Okay. This thing does not happen. Yeah. So any doubt in the determinant part?
No, sir.
Okay. So there will be few special type of matrices that will come or you will get to know in later weeks. Okay, so it's better to discuss that. Okay, that is, let's first start with these three. Okay, upper triangular, lower triangular, and diagonal matrix. Okay, so now, as I said before, that in matrix we have only one diagonal. Okay, that is this. Okay, where the rows and column position are equal. That is A11, A22, A33. Okay, only these elements are considered as a diagonal elements, and this is the only diagonal in a matrix. This one we don't consider as a diagonal. Okay, so upper triangular matrix says the matrix in which entries below diagonal has to be 0. Okay, that means this. Okay, if this case happen, then it is an upper triangular matrix. Okay, while for a lower triangular, it is saying the matrix in which entries above diagonal has to be 0. Okay, that means okay, this is an example for a lower triangular matrix. And the diagonal matrix is non-diagonal entries has to be 0. In bracket, it is also telling that diagonal entries can also be 0. Okay, remember this thing. Student often confuse in this definition that diagonal matrix does not put any constant on the diagonal element. Okay, the only condition for a diagonal matrix is non-diagonal entries has to be 0. Okay, that's all. Here diagonal entry can be 0. Okay, so that means if I have this matrix, now tell me, is it a upper triangular matrix?
Yes, sir.
Yes. Okay, is it a lower triangular matrix?
No, sir.
No, sir.
Okay, is it a diagonal matrix?
Yes, sir.
No. No, sir.
No, sir.
Okay. Yes,
No,
diagonal
sir.
matrix can also be 0. Okay. Oh, sorry. Yeah. 3 is. Okay. Now it will become a diagonal matrix. Now? Now it will be diagonal or not?
Now it's a diagonal
Yes.
matrix.
And what about now? Okay.
Also diagonal matrix.
Diagonal.
Yes.
Diagonal?
Diagonal matrix.
Yes, sir.
Is it upper
Yes,
triangular?
sir. Yes, sir.
Is it
Zero
lower
matrix.
triangular? Yes.
Both upper,
Both.
lower,
Yes, sir.
diagonal.
Yes.
Okay. All the three conditions satisfied by this. And
Yes, sir.
if in any matrices all the elements are 0, that matrix is called as the null matrix. Okay. Now,
Sir, in a diagonal matrix, the upper triangular matrix and the lower triangular matrix are followed.
yeah, yes. Okay.
Okay,
Every
sir.
diagonal
Okay.
matrix is both upper triangular and lower triangular. Okay.
Okay, sir. Thank you.
Here sequence is going like this. Okay. Like you cannot say every upper triangular matrix is lower triangular, but every diagonal matrix is both upper triangular and lower triangular. Every scalar matrix is both diagonal, lower triangular, upper triangular. Okay. And like this. Okay. Just these two cases doesn't fall together, rest other all. Okay. Till here. Okay. Yeah. So scalar is just simple that the if diagonal entries are same. Okay. Like okay. This will be an example for scalar. identity is just a special type of scalar matrix in which the diagonal entries would become 1. Okay. And
Yes,
this
sir.
identity matrix is often represented by I, capital I. Okay. And now comes the transpose of a matrix. Okay. The
Sir,
transpose of
identity.
a matrix. Yes.
Sir, identity matrix is also called a scalar matrix.
Yeah. Identity is a scalar matrix also, a diagonal matrix also, an upper triangular also, lower triangular also. Okay. It satisfies all the criteria. Okay.
So identity matrix, if the diagonal is 1, diagonal entries are 1,
Diagonal entries are 1.
then it's called the
Yes.
identity matrix, no?
Yes. Yeah. This is an example for identity matrix. Okay. Now transpose of a matrix. Okay. That of a matrix is given by swapping the rows and columns. Okay. That means, okay, this is my original matrix. I will swap the rows and column. That means the rows will become column and the column will become rows. Here rows is 1, 2. That will become my column. Okay. 3, 4. Okay. The swapping of rows and column is the transpose of the matrix. Okay. And that's the reason why the determinant of A and determinant of A transpose is same, because we can find the determinant along any row or column, right? So here if we find the determinant along this row, we can find along this column also. Okay. So that's why the determinant of A and determinant of A transpose is same. Okay. Now comes the part of symmetric and skew symmetric. Okay. Symmetric matrix is a square matrix that is equal to its transpose. That means A equal to A transpose. Okay. If we have any matrix in which A is equal to A transpose, then we'll say it is a symmetric matrix. Okay. While skew symmetric is A equal to negative of A transpose. Okay. Now how that matrix will look like? First consider the case for symmetric. Okay. Okay. Now what you can see? Okay. These entries has to be equal for a symmetric matrix. That means 2/1th entry has to be equal to 1/2th entry in the matrix. Okay. Same 3/1 has to be equal to 1/3 and 2/3 has to be equal to 3/2. Okay. Because now if you take the transpose of this matrix, you will again get the same matrix. Okay. This was the case for 3 cross 3. You can expand it to any higher order also. Okay. Now skew symmetric part. Okay. That is A has to be equal to negative of A transpose. Okay. This will be the, is you can say, my skew symmetric matrix example. Okay. What is the general form? First, all the diagonal entries has to be 0. Okay. The reason is why, if you take the transpose, okay, in the transpose in any matrix, the diagonal entries will remain as it is, right? If we take the transpose of a matrix,
And as the definition for skew symmetric says that A has to be equal to A transpose. So that means for any element A, it has to be equal to the negative of it, and it can only happen with the 0. Okay. So like if we have a matrix ABCD, its transpose is ACBD, and we are saying that it is a skew symmetric matrix. That means its transpose should be equal to the negative of it. That means A is equal to negative A and D equal to negative D. So that means diagonal element has to be 0 in a skew symmetric matrix case. Okay. While if we talk about the other elements, there has to be the different sign. Okay. In if we compare it with the symmetric matrices. Okay. Like here, there has to be the same, but here they would be of different sign. Okay. Negative 5 and 5. Is it clear? Skew symmetric and symmetric part? Yes. What's your doubt, Adi?
Why the diagonal elements
Yes.
are 0?
Why the diagonal elements are 0?
Yes, sir.
Are you asking that? Yeah. See, consider the case. Okay. If you have a 3 cross 3 matrix. Okay. Okay. What would be its transpose? A, B, C, D, E, F, G, H, I. Okay.
Yes.
And if I am claiming that this matrix is my skew symmetric, that means A equal to negative A transpose, right?
Yes, sir.
Okay. Now, first compare the diagonal element. Okay. If you take the transpose of any matrix, the diagonal element would be the same. Okay.
Yes.
So, I am claiming A equal to negative A, E equal to negative E, I equal to negative I. Okay. Tell me the real
Yes.
number for which this case happen. Only 0, right?
Yes. Was.
Right. For only 0 this case happen. Okay. And that's the reason that for a skew symmetric case, the diagonal element has to be 0. Okay. Any more doubt
Yes,
from
sir.
it?
Thank you, sir.
Yeah. Now the last part, that is inverse of a matrix. Okay. So inverse of a matrix is another matrix that when multiplied by the given matrix yield the multiplicative identity. For example, you can say AA inverse equal to, oh yes, what's your doubt, Disha?
Sir, can you please explain skew symmetric once again?
Okay. Yeah. A skew symmetric matrix. See, symmetric means what? A equal to A transpose. Skew symmetric means A equal to negative of A transpose. Okay. And let's say I am claiming that this matrix A, B, C, D, E, F, G, H, I. This is a skew symmetric matrix. That means if I take the transpose of this matrix, that is this ADG, BEH, CFI, and take the negative of this, okay, that means just multiply each element with negative, okay, then these two matrices has to be equal. Equal means what? Each entry in the matrix has to be equal. That means A equal to negative A, B equal to negative D, and so on. Okay. So from comparison, all the diagonal entries has to be 0. Because if A equal to negative A, this can only happen for 0. Okay. So one thing is this, that is for any skew symmetric matrix, its diagonal entries will always be 0. Okay. And what about the other entries? For a symmetric matrix, what? They has to be equal. For a skew symmetric, they has to be with equal but with different sign. Okay. Here it is 2. Here it would be negative 2. If here it is negative 3, this is which part? Third row, first column. That means in first row, third column, it has to be positive 3. Okay. If we check for this, this is third row, second column. That means second row, third column has to be -5. Okay. Is it clear now?
Yes, sir.
Okay. And inverse is simple. Okay. This condition. Okay. That is, if I am claiming that any matrix is the inverse of a matrix. First of all, inverse matrix only exists for a square matrix. Okay. Whatever the matrices that we have discussed, okay, all these matrices are the special case for a square matrix only. Okay. So does the inverse. So for inverse of a matrix, if I am claiming A inverse is the inverse for matrix A, then A inverse A has to be equal to A inverse, and that should give me the identity matrix. Okay. This is just the inverse of a matrix. Now, how to find that inverse? We will study that in week 2. Okay. Yeah. So, any doubt in these special matrices?
So can you show by an example the inverse matrix?
Okay, inverse matrix. Okay. So, let me take simple. Okay. Let's suppose this is my matrix A. Okay. Now, inverse only exists if first of all the matrix is square, and the second condition is the determinant is non-zero. Okay. These two condition has to be satisfied. Only then the inverse of a matrix A exists. Okay. Now, what would be the determinant of this matrix?
6.
6, right? One thing we missed that, like if the entries below the diagonal or above diagonal, like in the case for upper triangular and lower triangular, okay, these type of matrices, then the determinant for those matrices is just the product of diagonal entries. Okay.
Yes.
Okay. So from the property, we also know that the determinant of A is equal to 1 by determinant of A inverse. That means I can say that if we have a matrix A inverse, its determinant would be 1 by 6. Okay. Okay. Now, can you multiply these matrices and check whether we are getting 1 or not? One means the identity matrix. Okay. I hope we are getting right. Okay.
Okay, sir.
This is the like simplest example that I took. Okay. There's a way to find the inverse of a matrix that we will study in week 2. Okay. But here we find the inverse of a matrix to the determinant. Okay. Yeah. So now we have questions. Okay. So first let's do one thing. Let me take your doubt first. Okay. After that, if time left, then we will take the questions that I have with me, or else we will study these questions in our next session. Okay. So now those who have doubt from activity questions, please raise your hand. Okay. I will take your names and then you can ask. Yes. So Roshan, what's your doubt?
Yes, sir.
Yeah.
Activity question
What's your doubt?
1.2.
Okay, activity question 1.2. Which question?
Question number 6. 6 and 8, sir.
6. 6 and 8.
Yes, sir.
Okay. Question 6 and 8. Just a minute. Is my screen visible?
Yes, sir.
Like the noted. Yeah, that is visible, right? Okay. 1.2 question number 6 and 8. So, okay. See you can open the portal in your desktop. Okay, so because I can't share my screen with the portal right now. Okay, so I will just go through each options. Okay, for question you can open in your laptop or screen. Okay, so
Yes.
first option is if A is a square matrix of order 2, okay, and A square is equal to I, then A equal to identity or A equal to negative identity. So that means if this case happen, then either A has to be identity matrix or A has to be negative of identity matrix. Okay, so is it always true? Hmm?
No, sir.
Will this case be? Hmm?
No, sir.
No, right? This case need not to be always true. Can anybody give me an example of a matrix like that? Okay. Okay. Let's take the, can this matrix give us? Okay, no. See, for this you have to do some hit and trial. Okay. Okay, here one. Okay, we got a matrix identity, while my matrix A is neither an identity matrix or the negative of the identity matrix. Okay, so is the first option clear?
Yes, sir.
Hello. Okay.
Yes, sir.
Now the second one is if A square equal to 0 matrix, then A has to be the 0 matrix. Okay, this one is simple. Okay, you can take the example of this matrix. Change the position. Okay, so you got the 0 matrix. Okay, so this is an example. Okay, so for statement type questions, okay, some may be proved algebraically, but for some questions you have to do some hit and trial. Okay.
Yes, sir.
Now, I hope the third and fourth options, do I need to clear? Are they clear or do I need to show? Okay, let's go
Sir,
to the third option.
can you please explain?
Yes. Sorry.
Sir, can you please explain third and fourth option also?
Okay. Third option is saying that if A and B are the square matrices of order 3, A plus B is 0, then B is equal to negative A. Okay. No. See, I am taking the case for a 2 cross 2 first. Okay. A equal to this matrix and B equal to this matrix. Okay. Their addition would give me what? A plus E, B plus F, C plus G, D plus H. Okay. And they are saying that this is equal to 0 matrix. Okay. That 0 here represent the 0 matrix. Okay. Always if the 0 is written, then it means the 0 matrix. Okay. Now we got that okay. This we got. This means what? A plus E equal to 0, B plus F equal to 0, C plus G equal to 0, D plus H equal to 0. That means A equal to negative E. Okay. Or you can write E equal to negative A, F equal to negative B, G equal to negative C, H equal to negative D. Okay. And my A matrix was what? A, B, C, D. Okay. If I'm multiplying this matrix by negative, okay, negative A, negative B, negative C, negative D. Okay. Right. Adding these two matrices will give me 0 matrix, right? Only.
Yes.
Yes, sir.
Now, because here in addition, it happened coordinate wise. Okay. It will give us this result. But what if I tell that the product of two matrices is 0? Okay. Then is it necessary that one of them has to be the 0 matrix?
No.
No, right? Because the product of matrices happen in a different way. Okay. But for addition, if I am claiming that A plus B equal to 0, then you can say that B is equal to negative A. Okay. Now, while for the fourth option, it is telling that A is a scalar matrix of order 3. I have already told that what is a scalar matrix in which all the diagonal entries, a diagonal matrix in which all the diagonal entries are equal. So like this. Okay, this is a scalar matrix. And B is a non-zero square matrix of order 3. B is some different matrix BCD. And it is telling that the product of these matrices is 0 matrix. Okay. So then A is equal to 0. Okay. So let's do the product. It would be AB. Okay, then AC, AD. Okay, AE, AF, AG, AH, AI, AJ. Right?
Yes.
Yes, sir.
Now, then AB equal to 0, AC equal to 0. Okay, all that. Now, these are the real numbers. Okay, and we know if we are multiplying two real number and we are getting 0 as an output, one of them has to be 0. Okay.
Yes.
The product of two real number, if it gives us 0, one of the real number has to be 0. Okay.
Yes.
Now, to satisfy all the equations here, A has to be 0. Okay.
Yes.
Only then this case happens. Yes.
So non-zero square matrix means at least one element is not zero.
Yeah. At least
So,
one element is not 0.
so should
Okay.
A be equal to 0 in all cases?
Now, okay. Not in all cases. Let's say AB. Okay. Let's write this. AF equal to 0. AG equal to 0. AH equal to 0. AI equal to 0. AJ equal to 0. B is a non-zero square matrix. That means at least one of the entries is non-zero. Let's say here B is 0, C is 0, D is 0, E is 0, F, G, H, I. To make it a non-zero square matrix, we have to at least make one entry to be non-zero. If I am making J as a non-zero, A will automatically become 0, right? And if A is 0, that means my matrix is a scalar matrix, right? So this will become a 0 matrix, isn't it?
Yes, sir.
Yes.
Okay. So to satisfy all the equation, A has to be 0 here. If B is my non-zero. Okay. If B can be a 0 matrix, then it is not necessary. But if B is a non-zero square matrix and A is a scalar matrix and their product is 0 matrix, then A has to be the 0 matrix. Got it?
Yes, sir.
Yes, sir.
So sixth one is clear. Yeah.
Yes, sir.
Question number 8. Now, first two options, that there exist two matrices such that AB is equal to BA. Okay. First option. Or there does not exist any two matrices such that AB is not equal to BA. Which one would be true?
First one.
First, right? You can consider B to be the same matrix A for an example. Or you can consider B matrix to be identity matrix. Okay. However, this is not only the case. Okay, there are many such examples, but you can consider them as a like simpler example. Okay. Okay. So if I consider B to be my identity matrix, then this case would be true, right? Because AI is same as IA. Yes.
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 Okay. And there are more such examples. Simpler. Okay. So now third option is,
Excuse me, sir.
yes.
Hello. The real matrix means
Yes.
real matrix.
Yeah, okay, real matrix. Real matrix means the entries in the matrices are real number. Okay.
Okay, sir. Okay.
Now, third option is, there does not exist any real matrix A such that A square equal to A.
Identity.
You can take the case for identity, yeah. Null matrix also. And you may find other matrices too, okay, where this might happen. But these are the simpler example. Now comes the case for fourth option. That might be the doubt. Okay, where did the page go? Okay. Fourth question is telling that there exists a real matrix 2 cross 2 A such that A square plus A plus I is equal to 0. Okay. Now, I will not going to solve it completely. What you can do to check this is you can use the hint. Okay, like you can take an arbitrary matrix A, B, C, D, perform what it is doing here. What it is A square plus A plus I. Okay, first find A square. Okay, that would be BC AB. Okay, then plus A plus identity matrix. Okay, so that is A square plus BC plus A plus 1, AB plus BD plus B, AC plus CD plus C, BC plus T square plus T plus 1. Okay, and it is telling that it is equal to 0. Okay, now this will give me this expression. Equal to 0, AC plus CD plus C equal to 0, BC plus T square plus T plus 1 equal to 0. Okay, now you can simplify this expression. Okay, like we can take the B common from the first equation. Okay, B times A plus B plus A plus T plus 1. A plus T plus 1. Okay, then what we can consider from here is B equal to 0. See first consider this, that there are infinitely many solutions for these equations. Okay, so there exist more matrices like that, but what we need to find is one real matrix. Okay, so B equal to C equal to 0 and A plus D equal to -1. So we can go with A equal to 0, D equal to -1. Okay, so we basically need to try with this matrix whether it can satisfy. Can it? No, this one is not. Okay, so basically you need to simplify these equations and need to come up with one matrix. Okay, so
Like, how long do we go on, like, keep on doing the same thing?
no, don't like try with like some examples. Okay, try to take with go with the simpler matrix. Okay, like 1 0. Okay, these type of matrices which satisfy these equations. Okay, try
So
to take those values.
also in this question, you have assumed both D and what is inside the bracket to be 0. Like
No,
B into A plus D plus
0.
1 is equal to 0. Either one can be 0, right? Like for
Yeah.
this to be correct. So what are the other possibilities? It is like there are a lot.
See, if these two are 0, if I put them here, then we got D square plus D plus 1 equal to 0. Okay, this equation don't have any real solution. Okay, so that means we have to consider this exam. Okay, that is A plus D plus 1 equal to 0. Okay,
Okay.
so like that try to simplify the equations. Okay, and come up with one matrix.
So I add one matrix with this. 0 minus 1, 0 1 minus 1 minus 1.
0 1 minus 1 minus 1. Okay. 0 minus 1. Okay. minus 1 plus 1. Okay, now if you're going to add, yeah. Okay, now if you're going to add the identity, you will get the 0 matrix. Okay, this is one matrix. Okay, if you simplify more, you might get more matrices like that. Okay. Okay. Oh,
Sir, can you show that again once again?
yeah.
So can we like mock this up like an example, like a formula? This a square plus I plus a square plus a plus I equals to 0.
No. See, a square plus a plus I equal to 0. Yeah. What do you want to do with it?
Like, is it some kind of a general formula like later on?
No. See, this is basically, this question is for you to understand that some operations or something that might happen in real number case might not happen in matrix case. Like, if you carefully see this expression, okay? Now, same expression, if I write this, x square plus x plus 1 equal to 0, where x is a real number. Does this equation has any real solution?
No.
No. But in matrix, we have a real matrix, right? Okay. You can kind of relate that it is the kind of same expression, but for matrix, we have real solution. While for real number, we don't have any real solution. Okay. So these questions are basically for that purpose only. Okay. Yeah.
Okay, sir.
So any more doubt? Okay.
Sir, I
Let
have
me.
a doubt.
Yeah, I will go with Disha.
Okay.
Disha. Okay, I will go with Q. Yes, Disha, what's your doubt?
So I have a doubt in activity 1.1, question number 8.
Okay, 1.1 question 8. Okay, in which option do you have doubt?
Sir, can you please explain the graph? I did not understand.
Okay, for that, okay. A screen is visible, right?
Yes.
Okay.
Yeah, sure.
Okay, see. Uh, okay. Okay. Yeah. See, we have vectors A minus 1 comma 2 and my B vector 2 comma minus 2. Okay. So the V2 vector that you are seeing here, okay, this is my A, okay,
Yes, sir.
and this my V5 vector is my B vector, okay. Now in the question they are telling V1 represent a scalar multiple of A. Now V1, okay, V1 is this vector, okay. See, if it's going to be a scalar multiple, then it should be in the same, you can say, same direction, right? Okay, with more, you can say, length. Okay. Let me show in. Okay. Not in GeoGebra. Okay. Just a second.
Uh, Hi. So the Maths 2 instructor sessions are going to be like on certain 2 weekdays and 2 TA sessions, and you can find all those links with like whether it's a TA session or an instructor session with the Gmeet link in your Maths 2 course specific calendar. And the calendar you will find in the course page in the about section. So just add that and you will know like which day what is. It's like on in an alternating pattern. So first instructor, then TA, then instructor, then TA. That is the general pattern for each week. Okay. Just add the calendar. It's going to be very convenient. So you'll also have access to the link there, the Gmeet and everything.
Ma'am, the open session and the activity session both are instructor sessions.
For Maths 2, you have open sessions and activity sessions. I doubt that. Maths 2, I think it's just week one session and then another session. I think that is the
On
pattern.
Thursday, that's tomorrow, right? Yeah. Tomorrow we have activity session for Maths 2.
Yeah, that is instructors. So if
Okay.
it doesn't say TA session, then it's an instructor session.
Okay.
Yeah.
Yeah. Okay, so this is one graph you can see. Okay, here if you are able to see this U, okay, this is 1,3, and there's this alpha U equal to 2,6. Okay, that is the 2 times U. Okay, that is the scalar multiplier. Okay, now as you can see, this U and its scalar multiple vector, okay, both are in same direction, right?
Yeah.
Yes, sir.
Okay, it is just that the scalar multiple would have more length. Okay, so kind of like that. Okay, so of course V1 cannot be the scalar multiple of V2, right?
Yes, sir.
Okay, now V2 represents a scalar multiple of A. See, A is TL this
Could
arrow.
you explain the first option again? Why A?
V1 represent, okay.
Oh, okay. V2 is equal to A. Okay, got it.
So
No,
the scalar multiple must be longer than
no, it not be the longer. If you multiply with half A,
okay.
it just that it should be in the same direction. Okay.
What
Right
if
here.
it is negative? Scalar is negative.
Then it would be like in the opposite. Okay, that depends upon the what kind of multiple it is. Okay.
It can be in the opposite direction.
Yeah. Okay.
So in this case, first option is wrong because A is equal to V2.
No. Okay. See, V1 is this. Okay. V2. If you see the vector V2, okay, there's one arrow in the middle of V2, right?
Yeah.
Till that vector is my A. Okay.
Oh, okay.
Okay, and like here, you can see the arrow, right? One blue arrow is there.
Yeah.
Yes.
Okay. And the purple arrow, okay, consider that purple arrow to be your V2, while till your blue arrow, that is your A. Okay. Same like this here. Okay.
Yes, sir.
Okay. Now V2 represents a scalar multiple of A, right? Just like case here. Okay. Are you able to relate that?
Yes.
Okay, great. Now V5 represents a scalar multiple of B. Okay.
Yes.
B is the total error. Okay. V5 is the half part of B. You can say kind of. Okay. Got it?
Yes, sir.
Yes, sir.
Now, next is V1 represents a scalar multiple of B. V1 and V5. Okay. Those two, okay, they are not exactly in the same direction also. Okay. And I guess here it is. Okay. Again. Okay. If okay, yeah, we were on the point. This, yeah, V1 represents a scalar multiple of V. Can V1 represent a scalar multiple of B?
No,
No.
sir.
No. Okay. If it was also there, it should be, you can kind of say, in the straight line with B. Okay. While it is like slightly curved from there. Okay. Like it is totally not in the same direction. Okay. Upwards. Okay. Like if this is B, okay, it is not going straight in this direction. Okay. This is like this. Not exactly straight, it is there. Okay. It should be exactly straight line. Okay. Now
Yes.
V4 represents a scalar multiple of A plus B. Okay. What is my A? Minus 1 comma 2. What is my B? 2 comma minus 2. What is A plus B? Hmm? A is 1 comma 0, right?
A plus B is 1 comma 0.
Okay. And what is my V4 vector here? It is also same. Okay. 1 comma 0. We will consider this as a 1 comma 0 here only. Okay. Don't go like it's not written or like that. Okay. It is 1 comma 0. Okay. Yeah. Okay. And the last option, V3 represents a scalar multiple of A plus B. A plus B is 1 comma 0. That means its scalar multiple would be the x-axis. Okay. But V3 is not in the x-axis, right? Okay.
So scalar multiple means you can multiply it with another real number, right?
Yeah.
So it can be like more than 1 comma 0 also, right?
See. Okay. What we got as a plus b is this. Okay. 1 comma 0. Now, if you are going to multiply this vector by any real number, you will get alpha comma 0, right?
Yes,
what
sir.
is this alpha comma 0?
X-axis.
X-axis, right? That means either it will be in this direction or it in this direction. Okay. Got
Yes,
it?
sir.
But
Yeah.
where is my V3 here? Okay, V3 is, as you can see, V3 is, you can say, kind of 45 degree from the x-axis. It is, you can kind of say, x equal to y line.
Yeah, my doubt is V4 is not the only solution for the scalar multiple of A plus B. There could be others as well.
Yeah,
Not just 1 comma
there
0.
could be other. Yeah. Like if I have said okay, this can also be a scalar multiple of A plus B. Okay. So V4 is not the only one. There might be other.
Yes.
Okay. Yeah. So one. I hope the questionnaire is clear now. So,
Yes,
Preena
sir.
Salim, what's your doubt?
Sir, can you solve question number 5 from
Um,
1.1 only?
so my doubt is this matrix, it's a 3 cross 3 matrix, 3 2 2, 2 3 2, 2 1 1.
3 2 2.
2 3 2, 2
This.
1 1 1. Can you show how to find the determinant with respect to the first column?
Okay. And please, as I said, I will go with the queue. Okay. So those who have raised their hands, okay, I will go with the queue only. Okay. So with first column, that means this, right?
Yes.
Okay. So first is 3. Okay. Had all the entries this. Okay. Left with this sum matrix. Now, what would be the sign of 3 here? Positive or negative?
Positive.
Positive, right? Okay, that's good. And the determinant of the sum matrix is?
3 minus 2 1.
Okay. Now next would be 2. The sign would be negative. Okay.
Yes.
And okay. If we remove this. Now for 2. Okay. This is my sum matrix. Now what would be the determinant? 0.
Yeah.
Right?
Yeah, correct. 0.
Same for x. This. Okay. This is my sum matrix. The sign of 2 here would be positive 2. Determinant of this sum matrix is 4 minus 6, negative 2. 3 minus 4, negative 1. Got it?
Yeah. So now this is one of the activity questions. I forgot the activity number. It is also in solve with us question 10. So this is option 2, but it is showing +3 +2 +2, but it is marked as the correct answer.
Okay,
Because I didn't select that option, it is showing wrong.
Solve with us question number
10.
Okay.
Can you please see, sir, the second option?
Yeah.
Same thing was in one of the activities. I don't remember which activity it is.
It would be an activity, I guess, 1.5. Now I will show you what happened there. I got the question. In which option it was?
Second option.
Now, you are telling why the sign is positive for the middle two, right?
Yeah.
Okay. Now let's go back to the page. Okay. If we are finding with this, okay, my sum matrix is this, right?
Yes.
Okay. And then I am multiplying with negative 2.
Yeah, that part itself was different.
Now, it is different, right? The matrix here.
Yes.
Okay. Now, what they had did is 2, 2, 1, comma 2. They have switched the column. Okay. Basically, just like we have row operation, we have column operations also. Okay. And the effect is same. Okay. what the effect happen on the determinant with respect to row operation, same effect happen on with respect to column operation. Okay, so as interchanging row change the sign of determinant, okay, interchanging column also change the sign of determinant. So here, because of that, that 2 will become 2.
Oh, okay.
Okay.
Okay, so okay, sir. Thank you.
Yeah. Any more doubt? Okay, then Kushal, what's your doubt?
Sir, activity 1.2,
Okay.
question number 7.
Hmm.
Sir, I have solved this
E-
question, but I want to just cross check with. Sir, can you solve it again?
Okay. A is a square matrix of order 2 whose first column is denoted by C1 and C2. Okay. And B is B1 B. Okay. Now, the first column of AB is this. Okay. So A is my this matrix C1, C2. B is my matrix B11, B12, B21, B22. Okay. We have to find the
Sir,
product A. Yes.
sir, but the question is saying that A is a square matrix of order 2. So you have taken A.
No.
Sir, A must be a square matrix, na?
Yeah. See, basically, if you can consider this, okay, here this AC represents C1 and BD represents C2. Okay.
Okay, sir.
Okay. So that's what they are doing because C1 represents the first column of A, C2 represents the second column of A. That's why I have written it like this. Okay. Now do the product. Okay. If you do the product, you will get AB11 plus B21. Okay. Then AB12 and BB. Okay. Should I take a different coefficient? Let's take E. Okay. CB11, DB21, CB12, DB22. Okay. Now, first column of AB is, first column is this, right?
Yes, sir.
AB11 plus EB21. Okay. And CB11, DB21. Okay. So, if we have to see this, as a column vector. Okay, option is telling that it is B11 C1 plus B21 C2. So B11 C1 is A comma C plus B21 C2. C2 is E comma D. So AB11 plus CB11, okay, plus EB21 okay, I have added it differently. B11, it would be AB11 comma CB11 plus EB21 comma DB21. Okay. Now if you are going to add, you will get the same. Okay. AB11 comma EB21 and CB11 plus DB21. 2, 1. Okay.
Okay,
Is
sir.
it clear?
Yes, sir.
In same way, you can check for more options.
Okay, sir.
Any more doubt, Kushal?
No, sir. No, sir.
No? Then please raise, lower your hand. Okay. Vivek, what's your doubt?
Yes, sir. Sir, activity 1.1, question number 5. Sir, in that question, option A must be the right answer, but our portal has given the option B as a right answer.
1.1 question number
5. Question number
okay,
5, sir.
just a second. This question was from activity 1.2 question number no, I was talking. Now this is activity 1.1 question number
5.
5. Okay. So the correct answer that is given in the portal is A. And you are telling that the correct answer is?
Sir, option
According
B.
to you? B. Okay. So this is a follow-up question. Okay, first what they are doing is okay, first one is not relevant to us. C. Okay, in the fourth question, in order to improve her marks, Farzana undertook project work and succeeded in increasing her marks. Her marks became doubled for each exam. Okay, so that means Farzana mark would be the double. Okay. Now, following Farzana's improved mark due to her project, all students were given bonus mark in quiz 2. Okay, which is given by the column vector 10, 12,
Okay, sir,
15.
got it.
Okay, they are basically like following up from the previous questions.
No, what I did
Okay.
mistake, I thought that 21 plus 15, that will be added to 36. That was my mistake. But if we follow up the question number 4, in which the 21 is double to 41, 42,
42.
and 42 plus 15 is 57. That's the correct
Yeah.
answer. I got it, sir.
So because it is a
Thank you, sir.
follow-up question. Okay. Any more question?
No.
Okay, then next one is Roshan. What's your doubt?
Yes, sir. Activity question 1.3, question number 10.
1.3. Question number 10.
Yes, sir.
Okay. So you have given two system of linear equation. Okay, suppose there is another system of linear equation given by this for some real values mn and final. Yeah. So see, what you have to do is first solve the system 1. Okay. That is let's take okay. First solve the system 1. That is here x1 x2 equal to 0 x minus x2 equal to 5. So we got x2 equal to negative 5, and on putting that here you will get x1 minus 10 equal to okay positive 5. Okay, and similarly solve the second system minus 2x3 plus x4 equal to negative 5, 3x3 plus x4 equal to 5. If you subtract these two equations, you will get minus 5x3 equal to minus 10, x3 equal to 2, and on putting that okay minus 4 plus x4 equal to minus 5, x4 equal to negative 1. Okay, then put this value in this system. Okay, that is 1 minus 2 minus 1 times x1 plus x3. x1 is 5, x3 is 2, 7. x2 plus x4 minus 5 minus 6. Okay?
Yes, sir. Now got it.
Got it?
Yes, sir.
More way you can solve it. Okay?
Yes, sir. Thank you.
So, any more doubt, Roshan?
No, sir. No. Yes, sir. One more question. Above,
Yeah.
sir.
Okay.
Above.
Above. Consider a system of equations. If the given
Question
system is
number.
unique.
Question number 7. 7 and
7.
8. 7 and 8.
Okay. So, let x1 and x2 be the solution of the system of linear equation ax equal to b, then which of the following are correct options? So, see. 1.3 question 7 and 8. It is given that x1 and x2 are the solution of the system. That means ax1 equal to b and ax2 equal to b. Okay. These two system has solution. Okay. So now if I'm going to consider that, see, this is what? This is the matrix representation of the system, right?
Yes, sir.
Okay. So consider them as a set of equations now. Okay. Now if I'm going to add these two, what I will get? ax1 plus ax2 equal to 2b. Right?
Yes, sir.
I can take a common, x1 plus x2 equal to 2b. Okay. Similarly, you can subtract also. You will get a x1 minus x2 equal to 0. Okay. And these two are the options, right? That x1 plus x2 is the solution for x equal to 2b, right? That's what had happened here. x1 plus x2 is the solution for 2b, right?
Yes, sir.
And x1 and x2 is the solution for ax equal to 0.
Yes.
Okay. Got it?
Yes.
Same way you can proceed with the nth option also. Okay.
Okay, sir. Okay.
Yeah. Yes, Disha, what's your doubt?
Sir, I have a doubt in second question in same activity.
Okay, system 1 has unique. See, you can try solving the equation. See, one thing you can do for now is, if you got a square matrix as your coefficient matrix, okay, just like here, the coefficient matrix is a square matrix, and if the determinant of that matrix, because we can only find determinant when the matrix is square, if the determinant is non-zero, then the system will have unique solution. Okay. So you can try calculating the determinant of this matrix, and it will come as non-zero, right?
Yes, sir. So if
Okay, we can.
determinant, so if determinant of this matrix is not zero, it's zero, then
If it is zero, then there will be two possible case. Either it will have infinite solution or no solution. Okay. So I don't think so. See, infinite solution you have to like see the equation for now. That one equation might be the scalar multiple of another. Okay. That would be, you can identify that yeah, it is an infinitely many solution. Okay. Or in no solution case, what might happen is like this, that x1 plus x2 equal to 2 and x1 plus x2 equal to 5. Okay. If this is my set of equation, then clearly it will, okay, or let's consider this 2x1. Okay, let's do this, and then 2x1 plus 6x2 equal to 5. As you can see, the second equation is 2 times the first equation, but on RHS it is not the 2 times, so clearly it will have no solution. Okay, so like that you have to identify for now, but don't worry, in week 2 you will learn the procedure, okay, called the Gaussian elimination. Okay, like as I told, okay, these will be like basically your uh, topics in week 2. That first we will continue our discussion on determinant. Then one thing will come, that is Cramer's rule. Okay, that is also for solving system of linear equations. Basically whole week 2 is all about solving system of linear equation. There you will study it in detail. Okay.
Oh, yes, sir.
Okay. Yes, Preeti, what's your doubt?
So can you please explain the question 7, option B? I really didn't get the explanation.
Same activity.
Yes, sir. 1.3.
Option B. Okay, question 7. Okay, see, it is given that x1 and x2 are the solution of the system. We have a system Ax equal to B. Okay, x1 is one vector. Okay, let's say x1 is some values 5, 6, 7. Okay, this is one set of solution, and let's say x2 is 1, 2, minus 1. Okay, this is one set of solution. Okay, these are the solution for the same system of linear equation Ax equal to B. Okay, then if this case happen, okay, these are basically the solution. What I am doing is I am adding these two systems. Okay, if I will add, I will get this ax1 plus ax2 equal to 2b. Okay, then I can take the a common. Okay, then I will get a times x1 plus x2 equal to 2b. So this is basically what? A is my coefficient matrix. Okay, 2b is my resultant matrix, and x1 plus x2 is the variable matrix. Okay, so x1 plus x2 is the solution for the system ax equal to 2b. Okay, got it?
Okay, sir. Okay.
Yeah.
So one more doubt was like question 3. How options B and C are also correct? I was not able to. Same activity.
Which one?
Same activity. Question 3.
Which options?
Options B and C are also correct. I had picked option A, but then option B and C are also correct.
Okay. B and C.
Yes, sir. Question 3 of 1 point activity question 1.3.
Okay. If each equation of a system of linear equation is multiplied by a non-zero constant C, then the solution of this new system of equation is C times the solution of the old system of equation. Okay. To the solution in the system of linear equation Cx equal to B. Okay, are you sure B option is correct?
Sir, B option is not correct.
Yeah, B option will not be the correct. Okay. I can tell, like, I guess these two should be the correct. Okay, just check. Okay, why it's not working? Okay, let me refresh the page. Okay, my screen stopped. Okay, my voice is audible, right? I am audible?
Yes, sir.
Yes, sir.
So my screen also froze. I'm just checking the answers, but I thought A, B, C were right. What was the right answer? Disha, can you tell me?
First, third, and fourth are right answer.
Okay, 1.3, question number 3. Okay, So let me again share my screen. Is it visible now?
No, sir.
No.
No, sir. Yes, sir. It's actually for A, C, and D are the right answer. Sorry. Actually, I had picked only the A option. I was not able to understand the other two options, which are how they were right. D option is not right, sir. I'm sorry.
Okay, just a minute.
Pulkit, I can share the screen if you
Yeah.
Okay. So we'll just go through this and then we'll end for today because it's already past 10:30. Okay. And we have our next TA session on Saturday, 27th. So we'll continue with week 1 there. All right. So this is the last one. I'll just share my screen.
Wait, Aradhana, just let me try once more, okay?
Okay.
No, it's not working, okay. Please share.
Okay. Which activity was it?
1.3.
Okay, is it visible? No, I mean the screen. I'll go to the activity now.
1 point, yeah.
Okay. Which question?
It was 3, I guess.
Yes, yes, sir. Definitely.
This one?
Third.
Third, okay. All
Yeah,
right.
so, okay, so for now, I will just verbally explain what is happening, okay? See, for the third option, it is given that x equal to b is a system of linear equation which has a solution, okay? Then the system of linear equation CAX equal to b, where c is not equal to 0, will also have a solution, okay? So one solution that it can have is 1 by c times x, okay? You can multiply the x matrix with 1 by c scalar, okay? And because that scalar can come out, okay, this will cancel out the c, and because it is already given that x equal to b has a solution, so the system Cx equal to b will also have a solution, that is 1 by c times x. Did you get that?
Okay, sir. Yeah, got it.
Okay, and same for logic for fourth option. It will be c times x.
Got it, sir. Got it.
Okay, so as there's this network issue for now, okay, sorry for the today's session because of the network. Okay, we will continue our session on when it is on Saturday, I guess. Okay.
Thank you so much, sir. Thank you so much. Thank you so much, ma'am.
Yeah, welcome.
Thank you.
And sorry for the disturbance that happened in the session. Okay.
No worries, sir. Thank you.
Yeah. Okay. So I will upload this PDF in the folder. Okay. You can access the link from the discourse. Okay. And Aradhana, can you please like drop the link in the chat box also?
Yeah, I've done that. And yeah, that's it. So, Pulkit, can you end the stream because I joined late, so I can't do that.
Yeah. What?
The yesterday's video is not uploaded, sir.
It is there. I send the YouTube channel link, right? I'll just show you.
Okay. See, if you
Yesterday's.
can see, do one thing. You can go on the YouTube. Okay. You can search MA1003. Okay. Just search MA1003. I am putting in the chat box. Okay. Search this on YouTube. Okay. You will get the Mathematics for Data Science 2 channel. Okay.
Right.
All the live sessions will be streamed. Okay, you will find it here.
And
Today's session is also getting streamed,
yeah,
and you will get that here also.
I
Okay.
got it, sir. Yeah.
and the
Yeah, I
link
was
I have
seeing
just
the
put in the
download
chat,
already.
the link that I just put in the chat, that is for yesterday's week 1 session. Okay, so you can directly go there.
Also there in the Google Calendar. Yeah.
Yeah,
Yesterday's video calendar.
yeah. Pulkit, please end the stream.
Yeah. Okay. So I'm ending the stream now. Okay, just I guess I have to join from here. Okay, I will just end the call then. Thanks for joining.